Awesome. We are between you guys and lunch, so we will try to keep this lively and engaging, or else.
That is so funny. That's not my picture.
Oh, God, that is
But it looks pretty close, so we'll go with it.
Yeah. It's a bad facsimile. You're much better looking.
Thank you.
I am so excited to be chatting with you, Caitlin. We have known each other for basically a decade and have talked about essentially every topic on Earth, but rarely in a work context.
Never.
Which is we met essentially through a mutual friend as motorcycling buddies, and so here we are. I run an early stage deep tech venture fund. We unfortunately don't have the privilege of investing in the startup that you are most recently involved with, which is OpenAI. But I am so excited for you and your career. And for anyone in the audience who doesn't know, Caitlin has had probably the most illustrious career at the intersection of game-changing design, novel technology, kind of what the future will look like in the next 10 to 15 years, and increasingly geopolitical strife, and we'll get into that in a minute. But you were the head of hardware of VR and then AR at Meta, and worked on game-changing products like the Quest. And then before that, you were at Apple and helped bring the MacBook, the original MacBook Air, to light, which certainly set for me the baseline of like what is exceptional hardware, what we should expect from functional hardware. I don't know if you guys remember this, I'm dating myself, but the Air fundamentally changed my opinion of what electronics in the hand actually should feel like, function like, enable us to do. And now you're the head of robotics at OpenAI, which, kudos, what an exceptional role. I don't know whose phone is ringing, and it's a great ditty. I'm super happy for you, but maybe you could shut it off. Thank you. There we go. No worries. What I am so interested by is that you have spent the better part of the last 2 decades building exceptional hardware. Robotics have always fallen short, in my opinion, as an investor and former roboticist myself, of actually landing as exceptional hardware in the market. What made you think that now is the time?
Well, thanks for the kind intro. It's great to be here, and thanks all for having me. Why robotics now is, I think, a contribution of several trends that appear to me to be hitting all at once. It's unclear when they're going to all take off, but right now a few things are happening which is kind of interesting. The most tactical is that you can start to really get custom robotics hardware at scale. This is the beginning of the time where you could say, hey, I want to go buy an actuator, I need these specs, and someone could actually build it for you for the first time right now. So that's great. But in terms of AI, RL is changing how those actuators move the body of the robot. And so up until now, we used classical control systems to write out differential equations and figure out how to make movement. But we're at a point with RL in AI where we can actually look at movement in the real world and copy it in a way. And you see I don't know if anybody saw the Unitree video, the Unitree dancing or the dancing robot dog, but a lot of this is RL. And that's really fascinating because we can actually approximate movement types. And there's a few benefits of that. One is you actually don't need quite as fancy components because you can use basically mimicry to make the device move the way you want. But also because, and we'll get into this I think a little bit later, there's acceleration happening. And so there are these acceleration curves. One of the third thing is the Sim2Real ratios changing. And for folks who aren't roboticists or AI people, I think everybody here is an AI, so you guys probably already know this, but how much simulation does it take to make a robot do what you want in a computer versus in real life, and how much training in real life? That ratio is changing. So there's more and more and more sim and less real required. This is an acceleration curve. So there's all these acceleration curves that appear to me to be adding up. And I think I've told you this, but I have historically, as a consumer electronics person, worked on a linear curve of improvements year over year. And this is my chance to hop on an exponential curve like all my friends and like you in AI and Silicon world. So I'm excited about that.
May we all be on the right exponential curves.
I want that on a t-shirt.
I think you said something really fascinating. I kind of want to double click on this point because I remember basically the better part of a decade ago, well, 2 decades ago, I was working on driverless cars back at Carnegie Mellon, and we kind of thought that we might be in a simulated data environment. Then the better part of a decade ago, the first iteration of Waymo, Zoox, basically came out of the gate saying, we can simulate the real world, we don't have to drive all these miles. And then turns out Tesla kind of has beat the pants off of everyone in kind of actual autonomous driving because they had the miles driven. Mm-hmm. And so you're saying now that we're starting to hit that inflection point where the simulated data is starting to get sufficient such that we don't have to have a basically 10-to-1 real data versus simulate data. That's the reason to jump in on this, right? This embodied AI, if you can actually simulate the data, because I don't know how we can continue justifying PhDs sitting in warehouses folding T-shirts, which is wild to me. And if you guys are folding T-shirts, then kudos. But maybe we should make some videos doing that instead.
Exactly. And like I don't want to get into details, but the perturbation of the simulation is just yielding more and more benefits than we thought.
So if we believe that we can kind of virtualize these systems such that we're building more clever systems without having first to see an embodied instantiation in real space, how does that actually translate to the hardware? Like, how do you design hardware, or what's different about how you're designing hardware now or thinking about it in a world where theoretically your system's getting smarter as it's out in the world and operating?
Yeah, you want to try to make the hardware smarter in advance. So this is tricky. You're like if you're designing a computer, you kind of know the silicon that you're going to put on it. Then you figure out the display. Then you figure out how all the pieces go together. But with robots right now, you have to, the thing that the robot can do is going to materially change. There might even be new kinds of AI that don't even exist today that you want to put on it. So you kind of want to try to future-proof your design as much as possible. And I think the way I think about this is actually, our hope is, that if we were to design a robot now and we were able to teleoperate it to do whatever we wanted, that our hope is by the time we want to ship it, that it will be able to do those things autonomously. And that's the way that we're approaching it. So basically, we're trying to create robot hardware that can do everything we would want it to do in a teleoperated sense, and then shift to having it run on AI by the time it gets released as much as possible.
Yeah, it makes sense, right? Because otherwise you're in a lagging cycle and kind of can't afford to be. I'm deeply pessimistic that this is all a race to the hardware, a race to the bottom on the cheapest possible hardware, and this construct that smarter models will make up for worse systems. But as a recovering engineer myself, I just don't see. I feel like there's a bottom line on how basic, incompetent, irrepeatable the hardware can be. Yeah. What's your take on that?
I mean, I'm a hardware engineer by training, and everybody's got hardware that's broken on them because it wasn't good enough, or it didn't it wasn't thoughtful enough, or it didn't solidify, harden the right parts or whatever. So I don't think there's a race to the bottom on hardware components. I do think that RL gives us a chance to use less sophisticated high-end components and merely high-end components. And that, the difference in the delta in cost is quite high between those two. But I don't expect we're gonna have $200 robots that can do things that you'd want them to do other than maybe vacuum and sweep.
In which case, there's pretty good vacuum robots out there.
Exactly.
Our mutual friend, Rodney Brooks, has been building them for a long time.
Yeah.
I guess that there's one trajectory of, can we build the idealized system? But then maybe the more interesting question is, in the long arc of these systems proliferating our existence, our factories, or whatever the use case is, you probably need a lot of embodied AI, which means we need to figure out how to build a lot of these systems. And in a world where we're used to building a lot of systems in China, and we may not have that privilege for much longer. How do you think about the supply chain problem, both from a subcomponents perspective, an assembly perspective, maybe even an engineering partner perspective?
I mean, this is what keeps me up at night. Not the way how we design our robot, not the AI, actually, although those are very difficult both. It's the supply chain and, oh, they got my picture right. Thanks, guys. It's the supply chain and how do we do final assembly and where do we do final assembly and then where do we get the components? And my sense right now is tariffs are going to have an effect on this. And it's unlikely that tariffs will not affect us. Even in, 1 to 5 years, there will be a tariff impact. But there's also, increasing geopolitical tension with China. And in my history, in my career, the last 20 years, we've made almost everything in China that I've made. And so my guess is we're going to start to look at hybridization. We have historically looked to China to help us think through our final designs. And we've typically paid them, if we're not going to go to volume with them, something called NRE to pay for their engineering efforts. My guess is that will continue actually in many cases. And the production may move out of China. And we may work with the same companies or different companies to produce those, the final assembly or the components outside of China if we have to. But my guess is in some cases we'll just have to pay more for those components. So,
in my memory, you're probably the best positioned of almost anyone on Earth because I think it was in 2019 that you were trying to get the Quest shipped. And I don't know if you guys remember this, but in early 2020, we had kind of a global snafu in terms of our capacity to operate cross-border and ship things. Like, you guys still shipped on time and on budget.
Yeah, the Quest 2, we did. So we were in like halfway through the engineering builds, December of 2019, and then of course we had COVID, and we had to ship anyway without being able to go there. And then part of the fun is our display supplier was in the Philippines. The Philippines shut its borders. They shut down. Nothing happened in the Philippines for the next, I think, 6 months. So we had to move our factory from the Philippines to China to make those displays. And like we still hit our schedule. So these things are possible. I think COVID helped us realize that they're more possible than we ever thought. Because if you told us beforehand, we would have said it was impossible, right? So I do think that there was some pressure from COVID that we learned a lot about what can be done in supply chain. I hope that informs this next phase.
Do you think this kind of manufacturing ever moves to the US? I'm pessimistic on this construct.
This is a great question. I mean, there is another exponential that's not as near to now. And I don't know when this is going to happen. But I do think that there's a world in which we have industrial robots. So they're fixed robots, robot arms, the kind you see making cars, make robots. And then you really have some interesting questions if you're not paying as much for human labor as, like, let me back up. Before COVID, we were making the Quest. And then after COVID, we went back and checked the factory. And the factory line that had 100 people down it putting components together, turned into a line with 4 people. And you had these cabinets and you had these automated things putting the product together and going down the line. And it was incredible to see it. And it happened all during COVID when we couldn't go there. And by the time we got back, it wasn't, I think it was the Quest 3 actually. It wasn't my product at the time. But we got to see it and it was automated. And that was actually one of the catalysts for me ending up where I am now, which is a realization that manufacturing is going to change significantly. The benefit that we have, though, that's not going to change is the constellation of all the other stuff we need. When we made the Mac Pro, we moved it to Austin, Texas from China. And I called a guy on a Friday at 4 p.m. and I was like, hey, I need some custom screws. And he was like, well, I'm going home right now, but maybe in 3 weeks we can make them for you. And like in China, if I called somebody at 4 p.m. on Friday, I had the screws the next day because they were like across the street.
Right.
And so there's a lot going on here where there's this constellation of, part of the reason Shenzhen is such an incredibly successful area is you can do everything vertically right there.
Yeah.
So not only do we have to think about labor costs and labor availability, it's not just labor costs, it's like, are people willing to do this in America?
Right.
And I think in many cases they won't be. So you got to automate that. But then you have to think of the constellation of the components coming in. And that's where I think it will take time to change supply chains.
I think that's the challenge, right? It's that I used to work in the aerospace industry, and it's never the constraint of exactly how do you assemble the thing. It's how do you get the rated screws so that you can get to the 10 to -9 safety, because every subcomponent has to be tested. Obviously, we're talking about probably different levels of safety requirements here, but similarly, I think you make an excellent point that all these systems are integrated, and that for all of the advances that AI will enable us, including robots building robots, we're still constrained to physical space. And maybe those constraints, whether they be tariffs or supply chain challenges, breed the kind of creativity that we need to see.
I think they will. I just don't think it will be very fast.
Yeah. Traditionally, and again, coming at it from my background as a former engineer in the space and now an investor, we spend a lot of time trying to figure out how do you build the most efficacious team to go and run at the problem that you're trying to solve. And there have traditionally been basically a dearth of incredible talent in certain subspaces, like, frankly, firmware engineers. How, if at all, has AI changed your hiring plan as you think about building a team here?
Yeah, it's a great question. It hasn't changed my hiring plan. We've got many roles, including software roles, coming open, I hope, in about a month. Nothing's changing there. But I do expect that AI will change our ability to get more done with those people. And right now, so I come from consumer electronics into robots, so I'm using O3, the OpenAI O3, to learn about all the things that I just hadn't picked up yet about robots, about how actuators work, how gearboxes work, trade-offs, all of that sort of thing. And I have definitely probably 4x'd my ability to learn from using AI, and I expect that will be the big difference. But in hardware, you still got to make everything. You still got to make every component. You still got to do the CAD. You still got to do the board layout. And AI hasn't come for our field yet in a lot of ways. But on the software side, I would expect you can see a lot more efficiencies that way.
So smaller, better teams doing more,
and
ideally
different,
faster.
I mean, you really want agency and you want taste.
Yeah.
You want agency. You want somebody to be able to do things in a really efficient way. But you want the taste to know of all these ideas, which is the right one. And those are the two things we're really looking for in addition to technical excellence.
Yeah. I think the point that Jobs made back in the kind of height of his time at Apple, that the aesthetic choice is the correct choice, that appears to be even more true now, that kind of curation of decision making is the critical difference in the outcomes. Well, we're almost at time here, so I think I will just say that I, for one, am wildly excited about what you may or may not be building here, and to dispel. Unfortunately, we can't speak specifically about what Caitlin is up to at OpenAI, but I know that I'm waiting with bated breath because you've only produced exceptional things in the past, and so no pressure.
Exactly. Thanks for. We'll do our best.
Expect nothing more than that from you in the future, and thanks for taking the time, and thanks for being my friend, and thanks for the work you're doing in the world.
You're the best. Thanks, and thanks for having me, everybody.
I think you guys are off to lunch.
Yeah, I think it's lunchtime.